These two pieces of flat stock shall become the brake and rear bearing housing. Remember the two flats I milled in the rear of the body. That's where the rear bearing housing shall be fitted. I made a wooden mock-up of the shaft with a steel insert to center punch the center of the rear bearing housing. The thing is assembled and given a good whack with Mr. Hammer. The brake shall be fitted to the bearing housing by means of a dowel pin and two screws. They need to be bored together. The ends of the screws were slotted for reason that shall be apparent later. The bearing housing is mounted in the forejaw. The tip of a dead center is held in the center punch mark whilst its rear is held by a center in the tailstock. A DTI is used to monitor its wobble. The wobble is taken out in the same way as one would dial in round stock. Now that the bearing housing is centered, the brake is fitted to it. The slots in the screw ends were used to turn them by inserting a flat screwdriver in the threaded hole. They are then given a final torquing. The bearing housing and brake are drilled and bored. The brake shall be bored to the size of the shaft, and then removed, whilst the housing shall be then bored wider for a bushing. The bearing housing and brake are bored in tandem to ensure alignment. That's a nice fit. The brake is removed so that the bearing housing is bored out to accept the bushing. The bronze bushing shall be pressed in. When pressing in a bushing, one must account for the reduction in the internal diameter. Now let's see if all the trouble was worth it. Fits snugly with no binding, nicely aligned. The brake was drilled and tapped for the actuating screw, and cut to form a flexure that will clamp onto the shaft when actuated. The bearing housing mounting screw holes were drilled and tapped. This is the nut that shall preload the bearings. I use a hole saw to hog out the bulk of the material. The hole is bored to size. Here I am using the swing internal thread tool of my design. The cutting tool swings away from the workpiece to clear the threads. Perfect fit. A spigot is turned on the nut face so that it only contacts the bearing in a race. Furthermore, a seal shall be seated on this spigot to prevent ingress of foreign material into the bearing. The bearings are preloaded. And it turns without binding. And it is already looking the part. Despite all the carefuling that I put in, I was shocked to see a 0.15 mm runout. So I checked the El Cheapo needle roller bearing, which is critical to the accuracy of the shaft. Turns out there was around 0.02 mm variance. This was due to varying thickness of the races. It explained the slight drag I was experiencing when rotating the chuck, occurring when the high spots on both races met. I decided to grind the races. The races were uneven. The magnetic chuck compensates for any spring in the washers, which would be also taken out when the bearing is tightened. Performing the same check on the lathe, there is minimal runout. I was getting 0.09 mm before. The runout is down to 0.06 mm, which is in the ballpark of the 3-jaw chuck's runout.